All right. Good day to us. All right. Good day to us. Welcome again to day three of the free ISC2 Certified in Cybersecurity Bootcamp. So today, as promised, we're going to start with three sample questions from Domain 2 and also three sample questions from Domain 3. So again, Um, just like yesterday, if you know the answer to any of the question, just type it in the chat, and so we I will be looking at the chat for your responses. So we hope others will join us as soon as we start. All right. So the first question from domain two. Now here is the question. The question says the primary objective of a business continuity plan is what? If you remember, we talked about business continuity plan yesterday, right? So, what is the primary objective of a business continuity plan? Is it A, to regularly verify whether the organization complies with applicable regulations, or B, to sustain business operations while recovering from a disruption, or C, to restore the business to the full last known reliable state of operation, or D, to assess the impact of disruption on a business. So, what do you say is the answer? You can use the chat. So, just type A, B, C, or D. So, what is the primary objective of a business continuity plan? So, I'll give us like few seconds to answer that. It should be pretty straightforward. If you really understood the business continuity plan and you read the domain too, so this should be a walk in the park. So Emeka is saying to sustain business operations while recovering from operations. So of course, that is the primary objective. You're very correct. That is the primary objective of a business continuity plan. Well done. So second question from domain two. Now, which of these is an example of a privacy breach, right? Which of these can we say it constitute or is a typical example of a breach of privacy? Is it A, access of private information by an unauthorized person, or B, any observable occurrence in a network or system, C, being exposed to the possibility of attack, or D, unavailability of critical system? So what option will you go with? If you take the exam today and you this question come up, so what which of the options will you go with? Okay, someone is saying A, access. Okay, now we have two different options. So Falakumi is saying A, Meka is saying C. So what is privacy breach? Privacy breach is someone who does not really need to know something coming in contact with that thing. And that means an unauthorized person accessing your private information. We have some information could be public, meaning information you can easily get online, on the internet, or on your social media. Those ones that are public, so there will not be any privacy breach in that. But when you have a private information you want to keep away from the public eye, if you have someone who you did not give authorization coming in contact or being able to have access to those information, that will be considered a privacy breach. So the correct answer is A. Then the final question from domain 2 is a security professional should report violations of a company's security policy to who? Yes, if you work in an organization and you notice violations of a company security policy, who do you report to? Is it to the ISC2 Ethics Committee? Is it to the company management? Is it to the national authorities? Or you're going to go and approach the court of law? So which option will you go with? Yeah. Okay, Meka is saying B, the company management. Do we all agree with company management? So since is the company's security policy, you can't go and approach the court of law in this case, or you can't go and approach the government, the national authorities, or you can't go to ISC2. So it's an internal affair. So you're going to report to the company management. Well done, guys. Well done, guys. I'm impressed. Now, before we start today's activity, we also need to look at three questions from domain 3. If you remember yesterday, we did a walkthrough of both domain 2 and domain 3, which is why we're starting with three questions each from them. Then when we're done with these, then we kickstart the walkthrough of domain 4, right? We have a lot to talk about in domain 4. So if you're ready, domain 3. Now, this is domain 3. Okay, let me remind us, domain 3 is on access control concept. We did discuss it yesterday, access control. So now this is the first question here. What is the most important difference between a MAC and a DAC? You remember what a MAC is? MAC is mandatory access control, while DAC is discretionary access control. I explained both of them yesterday, and I gave it in fact, I used example of a file. So is it option A, that in MAC, access permissions are set at the object owner's discretion, while in DAC, it is up to security administrator to access permissions? Or is it B, in MAC, security administrators assign access permissions, while in DAC, security administrators set user roles? Or is it C, in MAC, security administrators set the roles for the users, while in DAC, roles are set at the object owner's discretion? Or is it D, in MAC, security administrators assign access permissions, while in DAC, access permissions are set at the object owner's discretion? So which of them do you think is the correct option? Anyone? So let me just see your answers in the chat. Is it A, B, C, or D? The difference between MAC and DAC. Oops, looks like this is a tough one for us, right? I'm not seeing any options in the chat. Is this one tough? Well, I'll help you out. So the difference is actually option D. Because if you remember, MAC is mandatory access control, while DAC is discretionary. In DAC, you that owns the object. The object could be a file, it could be an application, it could be whatever resources you want to control access. You are the one that would decide who can have access to it, whether a read access, a write access, or execute whichever access. But in MAC, it is a security administrator that assign access permission. So you can't change once they've labeled something top secret and only few people can have access to it. You can't change it. While in DAC, you are the object owner is the one that can assign permission, right? So the correct option is D. Now let's look at the second question. This one should be pretty straightforward and simple, easy for us. Now, requiring a specific user role to access resources is an example of what? You see, the reason why I'm bringing this, some options in exam, they won't give you the full meaning of, they will just give you the acronyms. So you need to know what DAC is, what MAC is, what ABAC is, what RBAC is. Because if you know those ones to start with, you might face challenge in picking the correct answer. So requiring a specific user role to access resources is an example of what? Is it A, DAC, which is discretionary access control, or B, MAC, which is mandatory access control, or C, ABAC, which is attribute-based access control, or is it D, R, which is role-based access control? So which do you think is the correct answer? Okay, someone say D, which is RBAC, which is the role-based access control. So because they mention role, look at the keyword. In the question, there's role there. So automatically, that should just point you to D, a role-based access control. Thank you. Now, the final question on domain 3. Which type of security control does not include CCTV cameras? In other words, if you use a CCTV camera, what can it not do among all these? Can CCTV camera do detective? Can it do deterrent? Can it do corrective? Can it do preventive? Which one can it not do? Which one is not among of the capabilities of a CCTV? You know CCTV, closed circuit television, that little camera that you use for security purposes. So can it be used for detective? Can it be used for deterrent? You have to pick the one that CCTV cannot do out of these four options. So which one will you go, or which option are you going with? Is this one tricky too? I see a delay in our responses. Looks like this one too is tricky. Oh, if you know, okay. Can CCTV do detective? Yes. Can it deter some people? Yes. Can it prevent some people? Yes. But can it correct? Can CCTV correct? So the answer is corrective. CCTV cannot do corrective. Corrective means, can you restore something, an event that happened? It is just there. The lens is just there to just monitor. It cannot stop. It cannot correct what has been done, right? But it can prevent in the case, in the sense that, oh, some people might, you know, see that, and right when you spot something, then you can quickly alert security and they go and stop the person, so you can prevent. It can also do deterrent, meaning some people, when they want to carry out a dubious act, when they see the camera, then they refrain, right? It can also do detective, which is the core capability to detect from the camera. You see what is happening. So, guys, I believe now you gradually we're getting to understand the nature and structure of some of these questions, right? So without wasting much time, so we're going to go into the business of today, which is domain four. So domain four is a very important uh, aspect of cybersecurity, or IT generally. So you see, you can't claim to be a cybersecurity person and not to be able to secure a network, right? Which means you also need to have some knowledge of network. I'm not saying you should be a network professional, but at least enough to understand what makes a network, what are the component devices, what are the structures, what are the topologies, right? You need to be aware of, because you can't secure what you don't know. So just to let you know that in IT, we have a different career path called network engineering. So just for you to know, it's a very broad area. But we're going to try and walk through it in summary, so that at least you have a foundational basic understanding. And when you go back to read domain 4, you won't waste much time, and you find it easy to comprehend those things. But let me tell you, in all cybersecurity books, network security is a very broad area because of so many things. We have different kind of networks, you understand. So without wasting much time, let's walk through domain 4. Now, before we even talk about securing a network, what is a network? So a network is just as simple as it is, interconnection of devices. When you connect devices together, so they share resources, or they communicate or share resources, you form a network. Just for example, if you have a router in your house and you connect a device to it, or two devices with your IoT, with your laptop, your phone, you form a network, right? So just know that a network is the interconnection of devices together for them to communicate or to share resources, right? So in for you to be able to understand how, we said you interconnect devices together, they share resources or they share data. Now you need to understand how those data flow from device A in a network to device B, because so many things could happen. Attackers could, what you're trying to, let's say you have a typical network where you have device A and device B trying to communicate with each other. So many attackers could get in between the network and cause so many problems. They can prevent both devices from communicating, or they can steal private information, or they can, do all sort of attacks. So you need to know how data flow in a network. And two frameworks two frameworks that is widely used in to understand, to visualize, or to understand how data flow in a network. There are two. We have the OSI model. So we have two models. The OSI model, which is Open Systems Interconnection Model, which is what you can see here. Open Systems Interconnection Model. And we also have the second one, which is TCP, TCP/IP, TCP over IP. That is Transmission Control Protocol over Internet Protocol. You see this forward slash, you call it over. So meaning TCP over IP model. So again, we have two models for visualizing how data flow in a network. The first one is the OSI model. Full meaning of OSI is Open Systems Interconnection. Then we also have TCP over IP model. Now, TCP over IP model means Transmission Control Protocol over Internet Protocol. Now, what are these two things, right? I'm going to make you really understand them, right? You see, most organizations, right, they use either of them, right? Both of them, they do the same thing, right? Which is helping you to visualize how data flow in the network, right? They do the same thing. So some organization, they use OSI, some they use TCP over IP. But you as a professional, you should be familiar with both. Let's say you go to an organization and what they use there is TCP over IP, right? Or you go to another organization, what they use there is OSI. So you need to understand what they mean. Now, I'm going to show you. Now, if you look at this chart that I have here now, so this is the OSI model. It has 7 layers. OSI model has 7 layers, and you have to know this, right? You have to know this. It's if you want to use mnemonics, if you want to memorize it, please find a way to do that. But I know with time, like with time, I just get to know it, right? With time, as you use often and often, you get to know it. So OSI has 7 layers. Why the other one, TCP over IP, it has 4 layers. I will show you the TCP IP model later. But this is the OSI. Now, I'm going to start from bottom to the top. If you look at the bottom, I have the first layer there. Layer 1 is a physical layer. Layer 2 is a data link layer. I'm going to tell you what happened in all these layers, but let's take it one after the other. Layer 1 is a physical layer. Layer 2 is a data link layer. Layer 3 is a network layer. Layer 4 is a transport layer. Layer 5 is a session layer. Layer 6 is a presentation layer. And the topmost layer there is layer 7, which is application layer. So if there are two devices in a network, let's say device A, device B, let's say one is a client, one is a server. I'm not going to use device A and B again. I'm going to say one is a client, one is a server. If you know what this means in IT, client is just the one that requests for resources from the server, right? You can have a file on a computer that makes it a server. So other computer, they are going to request for that resource. So that makes them client. So we have client, we have server. So if you take it from client, right, or from server to client, so you're going to start with physical layer, layer 1, data link layer, network layer, transport layer, session, presentation, and application layer. Now, what is the physical layer? So physical layer is where you have the Ethernet, the cables, everything connected. If you have a router, I hope we all know what a router is, right? I hope I'm using a device that we are all familiar with, a router. So if you have a router, so a router, let's say you plug a cable, there's what we call Ethernet cable or the LAN cable. Let's say you plug a LAN cable there. So all those things, all those interconnection, the cabling, the cables, the wires that go into your system from that router to your system, those cables, they are where you have the physical layer, where you have the devices. And what happened there is the bit, the cables, your data flow. When you want to send a message from a client to server, the message is being converted into electrical signals. It's not as if it's your file that flow into the cable wire. The file are being converted into digits, bits, binary digits, right? And they flow into the cable. So that's what happened at the physical layer. Then at the data link layer is where you have a switch. I don't know if you know a network switch. If you don't know, you can just type on Google, network switch, select image. You will see the image. So a network switch will be what happens there. So network switch allow you to connect computers together to form a network. If you want to connect two or more computers together to form a network, so you connect them through switches. So that is what happened at uh, that layer. And what you have there is frames. Your bits from layer one is being converted to frames. We call it frames, right? That's where you have the header, the source. It will have the source address, destination address, so that you know where the data is going to. Then the third layer is the network layer. Now, the the data that was converted to bits, then to frame, will now be converted to what we call packets, because now they want to flow in the network, right? Let's say the client is in one location, the server is another different location connected by maybe Wi-Fi or something. They have to flow with signal. So you need a pack. They have to be converted to packet. That's where you have IP address. I know some of us will be familiar with IP address, Internet Protocol address. So that's what you have at layer three. Now, the transport layer is what do the control, the traffic control. There will be a lot of signals moving, flowing. So you have what we call the TCP there, TCP or UDP. These are protocols used. TCP means Transmission Control Protocol. UDP means User Datagram Protocol. In fact, if you join our boot camp, some of the boot camp that we run 3 months, 4 months, we spend a lot of time on network and we dissect all these things. Now we also do hands-on. You see all these things physically, not just saying it, you see them physically, right? But for the sake of this exam, I'm just trying to keep it as it is, just for you to understand, enough for you to understand and pass the exam, right? So at the transport layer, that's where you do the control and everything. Then you have the session layer, because for two devices to connect, for how long are they going to connect? You have to be able to manage the session. So all those things happen at the session layer, right? Then the presentation layer. What you have at the presentation layer is data compression, right? Some data, you have to compress them, right? Or you have to convert them from one form to another. All those things happen at the presentation layer, because you want to convert them in the form that will be understandable by the server. Let's say the message or the data is coming from the client. You have to convert it to a form that the server can understand. Or let's say the message is going from the server to the client, it has to be converted in a form that the client will understand, either way. Then the application layer is what you now have data that is now ready to be presented to the client or to the server, whichever way, meaning putting it in what user will now interact with, right? So those are the 7 layers of OSI. So we call it the OSI 7 layer, right? Now, look at the second one, which is the TCP over IP layers. Remember, OSI has 7 layers: the application layer, data link layer, the network layer, the transport layer, the session layer, presentation layer, then application layer. But look at the TCP over IP layer. It has just 4 layers, right? And the first layer, layer one, is a link layer, right? Similar to data link layer where you have the device. So the link layer here is doing the job of both the physical layer and the data link layer on the OSI. Then we have the internet layer. So internet layer is doing the work of that network layer. Then we have the transport layer, which is the same as the transport layer we have. The transport layer we have at layer 4 in OSI. So the transport layer there. Then we have the application layer. The application layer of TCP over IP is doing the function of the top 3 layer, which is the application, presentation, and session layer of the OSI, right? So whichever your organization works with, so you should be able to understand the flow. Again, in the bootcamp that we have that we run regularly, 3 months, 4 months that we run, these are hands-on things. I know when you get to do this and you see them, not just talking about them, and you understand, so you're going to get deeper knowledge about networks. But let's keep it as this, just so that TCP over IP has 4 layers, OSI has 7 layers, and both of them, they are just used to visualize how data flow in the network, so that you can, because at each of these layers, there are different kind of attacks that can happen, right? At the physical layer, there's an attack that can happen. Data link layer, different kind of attack. Network layer, transport, session, presentation, and application. So you should know how to secure each of the layers. That's why you need to understand the layers, right? Irrespective of which model are you going with, either OSI or TCP over IP, right? So now, another thing that this exam wants you to know is internet protocol. I mentioned IP address earlier. So what's an IP address? You see, devices need to communicate to each other. They need to have an address. Just like if I want to come and see you in your house, and you need to give me an address. Otherwise, I'm not going to know where I'm going to. So devices also have IP address that they use on the network, right? Those of you that are familiar with IT, you will have seen something like 192.168.0.1 or 246.225. Something like that. So those are IP addresses, right? We have two different kind of IP address, and you need to know them. So we have the IPv4, that's the Internet Protocol version 4. Then we also have the IPv6, that is Internet Protocol version 6. You can see them here. I have them on the screen here. So what's the difference between the two? Again, IPv4 uses what we call 32 bits, right? And because you see, because we have a lot of devices now in the market, both phones, laptop, computers, IoT devices, smart device, everything. So the IPv4 address will not be there won't be much address available to assign to devices, right? Because there are too many devices. So that's why IPv6 was invented, right? So IPv6 has 128 uses 128 bits. You see, that's quite larger address space than IPv4. Again, IPv4 uses 32 bits, right? 32-bit addressing, while IPv6 use 128 bits. But in summary, what am I trying to say? I'm trying to say that these are IP addresses that allow devices to be located on the network. So that you want to send something to device A, you need to know its IP address on the network. So when you go and read domain 4, you get deeper understanding about them as well. Then another thing in network, we have talked about LAN network. We have different kind of network. We have LAN, local area network, WAN, wide area network, WLAN, wide local area network. We also have network that you connect devices together without cable, which is wireless fidelity, Wi-Fi. Some of us are, in fact, I know most of us we are familiar with Wi-Fi. You go to a coffee shop, there's Wi-Fi. You go to a hotel, there's Wi-Fi. You go to in the airport, there's Wi-Fi. Or at home, you connect your devices, your TV, your everything through wireless. So Wi-Fi also has security risk. So you need to understand Wi-Fi. What is WPA? Wi-Fi protected access. How you can use WPA 2 or 3 to secure your Wi-Fi. So all those things you need to understand how it works. And also the OSI and TCP over IP model works for both. So I know some of you might have questions, but when I'm done with 4.1, I'll pause to take at least one question before I move on, so that it won't just be one way. But I just wanted to really, really listen and understand and keep notes if need be, and really follow along, so that later when you go and read the material, it'll just be a work in the park for you. Now, if you remember, I talk about devices on the network, right, being able to communicate to each other using their IP address. But how can you might want to use you might want to send multiple things to a different thing to a single device. So you need to use port, what we call a port. The way I can best explain a port is, for example, uh, you know, if you give me your address, the address to your house, which is your street address, on that street address, it is not only your house that is on that address. There are other buildings too, other houses on the street, right? So each of the buildings, they have their own number, the house number. So I would say, like, I'll use that analogy to say those buildings, they are like the port. So ports are like in numbers. For example, if you want to go to the house of Mr. A, maybe his house is house number 54. Maybe you want to go to the house of Mr. X, his house is house number 21, something like. So you need to have, uh, because they will share the same address, but you're sending the data to different units. Now we have a lot of ports, and here I have some popular ones for you that you can go through. So we have what we call FTP. So we have some ports are secure, some are not secure. As a security professional, you need to know the ports that are not safe to use and discourage your organization. You need to be able to give them an alternative, right? So I just have this screenshot here of popular port that I think you should be familiar with. We have FTP, which is File Transfer Protocol. It runs on port 21. So you need to be familiar with this. We also have port 22, this one here, which is SSH. SSH means secure shell. You see, FTP is used when you want to send files on the network, but it's not secure, right? That's why you see it under the category of insecure port. Then you can use SSH instead, which is terminal communication to establish communication with remote devices. Let's say your device is in a different location. I want to be able to connect to your device as if I'm on that device through terminal. I can connect through SSH. So SSH is a secure alternative for Telnet. Telnet can be used to do that, but it's not secure. It's dumb. You see all your credentials live. So, but with SSH, everything is secure. Then we also have SMTP. That's Simple Mail Transfer Protocol. It's used for email. Email communication, you use SMTP. But SMTP port 25, it runs on port 25. While the secure version runs on port 587, right? SMTPS. So this has to be SMTP, right? With TLS, Transport Layer Security on it. Then you also need to be familiar with DNS. DNS means Domain Name Service, which is uh, the service on the network that maps IP address to domain name, right? So you have that there. Then we have 443 as well. I think you should be familiar with these two, HTTP, which is it runs on port 80, but it's not secure. The secure version is HTTPS, which runs on port 443, right? So I don't want to bother you with too many ports for now, but just know port 21 FTP, port 22 SSH, port 25 SMTP, 587 for secure SMTP, 53 for DNS, 80 for HTTP, and 443 for HTTPS, right? So with time, you're going to be familiar with the rest. So now, what are the applications of network? We've talked about network being something the interconnection of devices together to communicate or share data. So what are the advanced applications of computer networks, of networks? So it's using communication, right, to communicate, whether email communication or voice communication, the VoIP, the voice over internet protocol, VoIP, or email communication. You can also use it for resource sharing. That's another one, application of networking, to share resources, right? Where you have a lot of clients requesting resources from the server. Then you can also use it for remote access. Remote access means, okay, you want to connect to a computer remotely. Maybe you want to use SSH, right? So you can also use it for online services. Online services like maybe web browsing. You want to browse is another use of network, or you want to do video conferencing. So those are the applications of network. So do you have any quick question here? I can entertain one question before I move to 4.2. All right. I guess we can continue. No question. So now that you understand to some extent, you understand what a network is. Now, you need to understand the threats and attacks that can happen. So we have different kind of threats that could be that a network will come under. So you can have a distributed denial of service attack. So what's a DOS attack? A denial of service attack is meant to compromise the availability of the CIA triad. Remember day one we talked about the CIA triad, availability. So a denial of service is usually used to compromise the availability of a network or a system, in this case of a network. But once it is distributed, and what does it mean? It means sending multiple requests or something directed to a single target so that it become overwhelmed. It cannot take it and it break down. Just like for a server now, you keep directing so many requests to a server that it cannot undo and is overwhelmed and is taken out of operation. So that's DOS. Now, what's a DDoS, which is a distributed denial of service? This is when attackers use multiple systems to attack a single target to bring it down. So it could be maybe they hack other people's computer and use them as a bot, right? A bot or a zombie. So the attacker is one controlling the attacker hack your system and is controlling your system to attack another person. So your own system become a zombie. Or maybe it's a network of attackers that they are like 100 and at the same time they are targeting one. Either way, they are sending overwhelming traffic to a single target at the same time to overwhelm it. So that's a kind of attack that could happen on a network. Another attack that could happen is virus, right? Of course, we all know what virus is. Something that compromise the normal operation of the target, right? Either to delete the file or disrupt operation, right? And we also have worms. So the difference between a virus and a worm is that a worm can self-replicate itself. A virus needs a medium like human being to carry it around. Just for example, if a flash drive is infected with a virus, once you plug into your system, so it affects your system. It needs you maybe when you now copy a file that has been infected on your own system, you copy the file to another system, then it will. But for in the case of a worm, once the worm gets to a network, it starts spreading by itself to others. So those are other threats to network. We also have Trojan. So all of them they are malware. You see, virus, worm, Trojan, we call them malware. Malware means malicious software, something that can disrupt the normal operation of something. So they are malware. So Trojan is a malware that appears to be something legitimate, but once you install it, it does some other thing. For example, let's say you just go on Google to download your favorite game app, right? And when you install it, then it installs something else and starts encrypting your files or stealing your confidential files and send it to attacker. You see, you'll be able to play the game. So meaning the danger is hidden in something valuable to you. So it's a Trojan. That's a Trojan. Then we also have MITM, man in the middle attack. When a network is established, device A is communicating with device B. So attackers could come in between and eavesdrop or try and get into the middle and steal or manipulate. Let's say Mr. A, let's say device A sent hello to device B. Attackers could change the hello to stupid or something dangerous, right? Or to change it. Or in some cases, they just eavesdrop, meaning they listen and steal whatever you are communicating. Let's say device A sent password or a secret password to password B. So attackers can just eavesdrop. Oh, this is the password. They steal it and they go and try it. Then finally, we have side channel attack. Side channel attack is a kind of attack where attackers try and study the operation of devices, right? Like the RAM, the CPU, the way they operate to steal, because there are information that random access memory. They Before you shut down the PC, there are some data that is there, right? That attackers could steal. So observing the power consumption of the server, the way it operates, attackers could steal valuable information from that. So those are kind of threats that example of threat that a network will be faced with. Now, how do you identify them? Of course, in your network, you should make sure you have an IDS. What we call an IDS is an intrusion detection system. So in our bootcamp, it's always hands-on. We are going to make our students to install IDS. An IDS, so you install it, you see the way it operates, you configure it yourself, you write the rules, and you monitor. You will set up a malicious network. You're going to do analysis, you dictate all those things so that it will not just be all theoretical. But for now, all I can do is just for you to understand the concept because this is just a crash course bootcamp. So an IDS is used to, monitor to detect anything according to the rule you set for it. You're going to write the rule, what you want it to monitor and detect. So once it detects it, it alerts you, right? Oh, there is a virus. Oh, there is a man, someone else. This IP is connecting to this that you're not supposed to. So something like that. And we have two kind of IDS. You can have the HIDS, which is the host-based intrusion detection system, and the network-based. So for the host-based, you will install the IDS software on the system or on the server. But for the network-based, it will be in the network, meaning it's not on a particular server, but it's in between the public internet and the device you're trying to connect to so that it dictates things in the network there. While the HIDS will dictate only on that system that it is installed. So again, that's to monitor. What about prevent? How do we prevent some of these threats and attack? So you can use an antivirus to stop a virus, a worm, or a Trojan, or I would say anti-malware in general. And also, if you do network scan, you regularly scan your network to detect rogue devices, that are not supposed to be there, or anything that is not working, or outdated software, our data application, our data operating systems. So network scan is going to help you as well. Then a firewall also can prevent, let's say you don't want so particular IP address from so region to connect. So a firewall can also help you to block. A firewall is just like a tool, a security tool that you can use to either allow or block or disallow something from coming to your network. Then also an IPS, right, can be used to prevent a network attacks, which is intrusion prevention system, right? You see, IPS is the opposite of IDS. IDS will only alert you in case it come in your question. IDS does not take action, meaning IDS cannot be a preventive control. IDS is a detective control, but IPS can prevent, making it a preventive control. So again, do we have a quick question here before I move to 4.3? I believe these are pretty straightforward, but you must understand network is a very wide area. But I'm just trying to make you really understand the concept. And once you grab this concept, what I'm explaining here, and you go and read the material, the domain for it to be a work in the park for you, trust me. And if you some of this in an exam, it's pretty straightforward. So do you have any question? Something that is not clear? Just quick question. All right. So let's just go on to 4.3. Now, 4.3 is now that you understand what a network is, you know the different threats and attacks that a network will come under, you know how to identify some of the tools you can use to identify and to prevent those threats and attacks. Now, you need to also know about the network security infrastructure. Infrastructure you need to have in place because you also need to have strong infrastructure in place that can support the network and that can prevent some of these things. So we have on-premises infrastructure, meaning the infrastructure you have in the organization, not in cloud. So on-premise will be the opposite of cloud, something you have physically in the organization. And you have to support a network with power. There has to be adequate power to it, right? The data center, the closet. You need to have what you call HVAC. HVAC is heating, ventilation, and air conditioning too. Because some servers, you need to maintain certain temperature level and humidity. So with HVAC, you can use it to control all those things. You also need to have fire suppression mechanism, something that you can be used to quench in case of fire incident. You also need to have redundancy. Redundancy, which is one thing also that can help you to stop DDoS, denial of service attack, so that if one server comes under attack, another server can pick up. And also, you can also have an MOU, memorandum of understanding or memorandum of agreement with maybe you have your organization have an MOA with another organization so that if their primary center is impacted by an incident, they can use uh, their location for as a secondary operation center. So that at least remember we talked about business continuity yesterday, so that the business can critical functions of the business can continue to operate. So you can have an MOA with them to share power. It could be an MOU or MOA to share power so that you both contribute to secondary generating power in case there's a power failure, or those things will help to make your network security robust. Now, what about the design? Now, by design to prevent some of these things, you can do network segmentation. Network segmentation is breaking your network into smaller units so that you can better put security measures in place. One important one you need to know is a DMZ. DMZ means demilitarized zone. So what a DMZ does is that you want to keep some computers or some servers private. You don't want it to be able to connect to the public internet, right? So, but at the same time, you want your user, your customer, to be able to access some resources in your network. So you just create a separate network, right, where your outside customers can connect to. Maybe there's a web server that they want to use some web application, right? They can connect to it. But between the DMZ and your internal servers, you want to put a firewall there, right? So that they cannot connect. So even if an attacker attack your DMZ, your private systems are still secure. So DMZ is used for that. Then we also have VLAN, which is virtual local area network. So a VLAN is a virtual LAN, as the name sounds, right? Which means you want people to connect together, even if you want them to form a network, even if they are not in the same physical location. Let's say you have a building that has office A, office B, office C, office D, and there are 10 people using computers in each of them, making 40. And you want to pick two out of those to form a network. You see, they are not in the same room, in the same office room, but you can connect them together and they will share resources, they will communicate as if they were in the same physical room, right? So that's what a VLAN does. So you also want to use a VPN, virtual private network, so that when you're connecting from your network, when you're connecting to an insecure connection, right? You want to be anonymous. You don't want your IP address to be known. You don't, and you want encryption so that you attackers will not, so that, because the public internet is a very borderless, and you don't know who is connecting, you don't know who is an attacker. So you want to connect with a VPN so that you securely connect whatever you are connecting. So it will be difficult for your information, IP address, and some of those. So everything will be secure, right? Then there's also micro segmentation, just like I said earlier, you break networks down into smaller pieces so that you can better put security measures in place there. Also, you need to know about defense in depth. When you do micro segmentation, then you need to put defense at every layer. You need to break your network down into layers and put defense at every layer. So you secure applications, you secure in fact, you need to do physical security, logical security. You still need to put monitoring systems, prevention systems. You need to put defense at every layer. Don't just say, oh, when we put something on this one should be secure. No, every layer should be you should have security controls at every layer of your organization, and that's what we call defense in depth. Then you can also have network access control. So what is a NAC? A network access control ensures that all devices that wish to connect to your network, all of them, they do so only when they meet some certain criteria. For example, you can say before any PC can join my network, they should have the latest operating system. I'm just giving an example. You can say they should be running latest operating system. Two, they should use a VPN. Three, they should have an up-to-date anti-malware. So any device that does not meet this criteria, you put them into a separate area that it is safe, that you know that even when they are there, they can't compromise your internet network. But once they meet this criteria, they're allowed to join the main network. So that's what a NAC does for you. And you can use even segmentation for embedded systems, for IoT. Now, finally, talking about cloud, because when we talk about network, IT has evolved. Now there is cloud computing and some of all those things. And even from your on premises, some organizations they have resources they access from the cloud. So you need to be worried about SLA. What's an SLA? Service level agreement. Meaning at the agreement you have that okay, the cloud company is going to provide so to us. Or like most cloud providers like maybe Microsoft Azure, Google Cloud, AWS, they have they make there are some promise or assurance they give their customers that maybe their server will always be 99.9% available or something like that. So an SLA just is a document that both parties say you're going to do X, Y, Z. If you don't do this, this should happen. So you need to have that agreement. Then managed service provider are those that help you to manage some functions of your business, maybe the data center or some other thing. Now, to wrap it up, cloud is being deployed in majorly three ways. We have software as a service, we have infrastructure as a service, and platform as a service. Now, what is software as a service? You see, when you use this cloud company and you use a tool, for example, if you use Dropbox, you know, if an organization is using Dropbox or they are using Microsoft Office 365, so you are not the one who built the server that's powering it. You're also not the one who owns the server. You're also not the one who built the application, the 365 application itself. You're just using the Microsoft Word online. All you're just doing is inputting your data, whatever you're typing in the document. So that has a software as a service. But when it comes to platform as a service is that the organization they provide you with the server, the operating system, and everything. So you build your own custom application that you want to use. Then you go and host the application in the cloud and use. So meaning you are using their platform. So that is platform as a service. Then we also have infrastructure as a service, which is the organization just provide the cloud company just provide you with um, the server. So you are the one that will install the operating system, the application, and the data, what have you. So these are the three major cloud deployment model: the software as a service, platform as a service, and infrastructure as a service. So you see, um, this now is just me giving you a summary of what domain 4 is about, which is network security. And I'm sure when you go and read domain 4 from the training material from ISC2, you're going to enjoy it and you're going to really understand it. So take your time to understand it, because there are questions like, let's go back to the, I think, is it 26% that comes from domain 4? 24%. Can you see it's the highest is 26% of your questions will come from security principle. The next highest is network security. So 24% of your questions will come from here. So guys, so this is what I have for us on domain for the summary. And I hope our reading is going as expected. If you follow the schedule, you're not going to have any problem at the end of the day. And like I said, I record all the classes day one, day two. Even yesterday class is on my YouTube, right? Is there today. Just search for Cyber Kazim. And please don't forget to subscribe, like, comment on the video or any other video that I have there. By Friday, the people who most engage on my channel is the one that will get the Udemy. But everyone who join this class, automatically they get a free 100 pass question. So I do take the attendance with Google Meet, and so I think we are all good. So if you have any other questions, anything that is not clear, we can continue on WhatsApp or on our Telegram channel. So thank you guys once again for joining today's class, right? See us tomorrow, where we'll start with 3 questions from domain 4, and then with this we walk through domain 5. So thank you. See you tomorrow.